Okay, aloha, my JSConf Ohana. Woo! I'm Crystal Martin. I am originally from Detroit, Michigan. I currently live in, where you at? Murderman. I currently live in St. Louis, working as a Salesforce developer at Slalom Consulting. So I'm in the St. Louis office. We're all over the country, all over the world. And I am a proud cat mom of 2. So I want to start with a story. Once upon a time, there was a junior dev that was given the task of integrating Stripe payments with Salesforce using JavaScript and Salesforce's Java-based proprietary language, Apex. Some of the questions that this junior dev asked. What is an HTTP request? What do you mean there is no Stripe library for Apex? What is Ajax? I thought this is what Ajax was. Like, none of this made any sense to me. I was lost. And my use of confused parrot here, when slacking my senior colleagues, increased immensely. He's my BFF. I am confused parrot. We are one. You see, I was writing code on the proprietary Salesforce framework called Lightning, which is based on the Aura framework, and it utilizes Ajax requests for server calls. And a lot of things are taken care of under the hood. So much like any other junior dev does, once I got the hang of the pattern, I knew what I had to do. I go, okay, I have to have a JavaScript controller, and it calls helper functions in another JavaScript controller, and then it somehow calls my server code to get data to show to my user. Okay, great. Why isn't this working? And I kept saying, my logic is correct. The way in which I made the request was correct. The logic I had to process the request was, the response that I got was right. But there was a fundamental misunderstanding I was having. I was trying to act on data that I hadn't even gotten back yet. And I was assuming things were happening in order. But I didn't understand this at the time, and when my colleague looked at what I was trying to do, he goes, it doesn't work that way. And I go, what? And he says, because JavaScript is asynchronous. What? Okay, yeah, okay. JavaScript is asynchronous. What? Like, what does that mean? I mean, I know what synchronous and asynchronous mean as words, like dictionary words, but like, I had no idea what this meant when it came to programming. No idea. And let me just stop here. We're not gonna get into this, nerds. Listen. Yes, JavaScript is asynchronous, right? I know that JavaScript isn't an asynchronous language, but it has capabilities that allow it to have asynchronous behavior. But just roll with it for the top, okay? You see, part of the problem here is how many self-taught coders learn online. We learn JavaScript like it always runs line by line, one thing at a time. And we get taught to solve puzzles rather than solve problems with the tool that we're using in the context of its intended use. So sure, I need to know what if else's are, and I need to know what for loops are, but they really discuss why JavaScript is the way it is. What does it enable a developer to actually do? So, you know, starting out, this isn't super apparent to a junior dev. We don't know about asynchronousness until we're dumped in a coding job and have to write JavaScript for, I don't know, the web. And then we're like, where are my fucking like for loops and cattle that I need to count? Like, I'm lost. So, you know, you're probably thinking, why is she talking about all this? But I want this talk to do 2 things. One, I want it to be something that can be helpful for new devs to understand JavaScript a bit better, and to show an overview of different ways that you can do asynchronous programming with JavaScript. And I basically wrote this talk because I wanted to break it down for myself. I was using something that I had no idea what was happening. And 2, I want mid-career and senior developers in the room to remember that most of the time we don't get taught this stuff if you didn't get a CS degree, or even if you did. And it's kind of confusing, and it's possible you take your understanding of this for granted. So my hope is that this talk will give you some intuition onto how to help someone better understand this. So let's get into it. But before we can talk about what asynchronous means, let's talk about what synchronous means. I'm gonna take a quick drink of water. So essentially, it means that things happen in order, right? Synchronously. One thing after another, step by step. But sometimes you need to make a call out to request data from an external system. And because those things take time, it can hold up processing of other actions that are independent of that data that you need. So if you wait for it to come back before you go on to the next step in your part of your process, you're wasting precious resources and that could be used to do something else. It's kind of like doing household chores. Say you need to clean up your house and do laundry. So usually I put a load of clothes in before I start cleaning to get that process going. I don't know about you. And if we're doing chores in a totally synchronous way, this will require us to put our dirty clothes in the washer and then proceed to stand there for 30 minutes as they wash, rinse, and spin before we can put them in the dryer for the next part of the process. 2 hours later, you're still standing there, the sun is going down. And in the meantime, I can't get anything else done. I can't move on to clean the bathroom or load the dishwasher, which leads us to a conversation on asynchronous programming. So what is this? It means things are happening at different times, not in sync. Processing the rest of the code doesn't stop if there's a process that requires time. So we just go along doing our own thing, and in this case, it'd be the rest of our chores. And when there's an indication that our asynchronous process has completed, we'll go on to the next step related to that. See, you do have to wait for your clothes to dry before you can fold them, unless you're weird. But you don't need to stand there and wait for them to get other shit done. And why do we use JavaScript for this? Well, JavaScript was written to deal with user interactions in real time in the browser. So users don't use the web in a synchronous way, which is something I would have kind of liked to learn about. You're interacting over a network connection, pulling data from external sources, which just takes time. And JavaScript was created to actually ensure seamless experiences for users on the web. So let's continue our conversation about asynchronous programming with JavaScript with a fun example that will help you learn something new about 2 things: JavaScript and the natural hair care process. Black Girl Magic for you and Black History Month. Okay, let's go. So naturals have this little thing called Wash Day. Hashtag Wash Day. I hear you. I hear you, yes. And so clearly this meme is a joke, but it isn't too far from the truth. Yes, sometimes I need the Holy Bible to help me with this process. But it's not far away from what a lot of naturals experience. And generally, I do this on a weekend day where I have some other chores as well, so I can kind of multitask. So if you don't know about the natural hair process, it's okay, you're going to learn. It's fine, just roll with it. So this is my do hair function, and just, this stuff is pseudocoded, so don't get all judgy, JavaScript developers. But here's my main process. This is my do hair function, so I'm going to walk you through it. So first, I have to do something called a pre-poo treatment. What is that, pre-poo? Well, sometimes I have my hair in protective styles like this, braids, right? Or I have a fro and it stays like that, and so I'm not combing my hair every day. So I have to put some conditioner and oil in my hair first and let it sit so my hair can get soft. And then I can go on to detangling, right? Because I can get softer now, I can get those shed hairs out, I can detangle it. And then I'll go ahead and shampoo my hair, rinse that stuff out. And then I have to deep condition it because I have to, put the moisture back in, let that sit for a while, rinse it out, and then air dry it. Air drying also takes time, and then I'll return my styled hair. And this is what my Saturday generally looks like. So I have my chores here. I usually do my hair, do laundry, clean litter boxes, clean the kitchen, clean the bathroom. So if I did this synchronously, in order, it would take a long time. So let's look at this. This is what my day would look like, right? I'd have my do hair function here, and I'd have to go through all that before I actually got to anything else in my do chores function. And I'm going to go into detail. So again, pre-poo treatment requires me to put conditioner or oil on my hair and do what? Wait, right? So I have to let it sit before I go on to detangle. So I'm waiting. And then I have another asynchronous process within do hair again, right? I have to deep condition my hair, let it sit, wait. And then I have to go ahead and do another asynchronous process, which is air drying my hair, and then I have to wait, and that takes even more time. So looking at the do chores function again here, I have 3 asynchronous processes, and it would take forever before I started doing anything else. Cleaning the litter boxes, doing laundry, any of that. So there's got to be a better way to do this, right? And there is, thanks JavaScript. Let's do it asynchronously with callbacks. So what is a callback? A callback is a function that is passed as an argument to an asynchronous function, i.e., a function that takes a while to complete some time. And it's called once the asynchronous, it's called once the asynchronous function completes. So to give you a little example here, this is a callback function. If I take a scared kitty to the vet, I need to comfort it when it comes back. And so I have an asynchronous function here called take cat to vet, where the kitty gets his temperature taken, gets a shot, and then is brought back home. This is the asynchronous function that takes a callback as an argument. So as you see here, the callback function gets passed by reference to take cat to vet, so the frightened kitty gets some TLC after visiting the big bad vet. Picture of happy kitty. So let's look at the callbacks and the do hair function. So to remind you of the process here, we're going to look at pre-poo treatment since it's our first asynchronous function and it kicks off the do hair function. So this is pre-poo without a callback. This is what I do here. So the function would just sit here while pre-poo was finishing, right? And this function would be considered a blocking operation. You know, you can't go on and do anything else in the do hair function, but I also can't do anything else in my overall chores function. So I'm going to go ahead and rewrite this as a callback. That way we don't get stuck here. Oops, sorry. So I have it taking a callback. Let's look at it. So, sorry. I have this function here is rewritten as a function that takes a callback. And we'll look at it in more detail from this point. So here is my pre-poo function declaration. And it indicates that I'm going to have a function that takes a callback. And so this is what my pre-poo treatment does, right? This is what the function does. I put conditioner oil in my hair, and I wait. And upon completion of the aforementioned process of putting the conditioner oil in my hair, I will call setTimeout, which is a method that will call a function, which in this case is our callback, after a waiting period. And now I'm going to go ahead and actually call the pre-poo treatment. But I'm going to go ahead and pass in my function, which in this case is an anonymous function that contains the rest of the natural hair process. And I've abbreviated it here, but you can see that just for clarity's sake. That's what we passed in. Now, you can also instantiate the callback function and set it equal to a variable and pass it by reference, but you'll see this done both ways. So this looks pretty good, but you know what? I need to add air handling. You know, sometimes my hair just isn't quite soft enough yet. You know, I put it in there and it's still feeling kind of tough. So if I started detangling my curly, fragile strands, it would not be good. So I have to add some air handling here. So if it's not soft enough, I'm going to go ahead and not do anything, right? Otherwise, if it's OK, I'm going to go ahead and go on to the next step of detangling and shampooing. Oh, but you know what else? I have some other asynchronous processes in here, right? I have to detangle and shampoo, which happen back to back, but deep conditioning takes time, right? I have to wait for that one, too. I have to let it sit. And you know what? Air drying takes time, too. So now I have a function that takes callbacks with functions that take callbacks. And this is what the do hair function ends up looking like, right? Now, partially, this is great because I have this asynchronous behavior, right, that allows me to go on and continue doing other things while I, wait for my hair to be done. But this starts getting hard to read, right? And what if there was another fellow like Natural Lisa that wanted to embrace her curls and follow my process? This would get really, really confusing to look at. And this is what developers call callback hell. It's kind of confusing to figure out what's happening here. It makes tracking down bugs difficult. And what if I added more asynchronous processes? Y'all believe it or not, I'm going gray at the age of 31. So sometimes I have to put color in my hair and let that shit sit, right? And then sometimes I have to do a clarifying treatment because I have to put so much stuff in my hair. So that's another asynchronous function or process that I would have to put in this do hair function. And like, this would get confusing after a while. So this functionality is great, but the readability is not so great. But there is a way you can rewrite asynchronous code so that it looks more synchronous, making it easier to follow, and that can be done by using promises. Promises. So useful, yet so difficult to understand when you're starting out, but I'm going to try to break it down, so roll with me. So what is a promise? A promise is a JavaScript object that will produce a value at some point in the future. Promises basically promise that they'll let you know what happened, right? Either it was fulfilled, rejected, or pending. And it allows you to act on your results with other methods. And then I have a promise object here, and this has two internal state and result properties and two method properties, resolve and reject, which we'll call and we'll talk about in a minute. And then I have .then and .catch, which are handlers for the asynchronous code's result. So it waits for asynchronous code to complete to then go on to the next process. And .then takes two methods as arguments. One, the first function is what happens when everything goes well, and the other one is what's get called when it doesn't go well. And .catch handles errors. So let's look at the promise anatomy with a pizza promise. So here I have a pizza promise. I'm sure you'd all like to have a pizza promise. Valentine's Day is coming up. Pizza promises. So the promise object's constructor has a function that takes the resolve and reject methods as parameters. And then there's some executing code that will return some kind of result. And so in this case, it's baked pizza, right? So we have baked pizza, that's our executing code, it's going to do something. And depending on what baked pizza returns, we'll either reject or resolve this promise. So here, if there's an error and say the pizza got burnt, I'm going to go ahead and reject with pizza error. It's a burnt pizza. Otherwise, everything's great. This pizza's perfect. I'm going to resolve with perfect pizza. And so now I can look at this, and I'm going to go ahead, and now I have a full pizza promise here, and I'm going to go ahead and call it, or call pizza promise with .then. And again, my first function in there is what's going to happen if everything goes well. So if I have a perfect pizza, I'm going to go ahead and eat that pizza. Or if it's burnt, it's trash, I'm going to go ahead and throw away that pizza. Promises. So we can rewrite prepoo, the function prepoo, as a function that returns a promise. And this enables us to go ahead and call other things on it. So here I have prepoo treatment equal to a function, an anonymous function, takes hair, it returns a promise. If everything's okay, if everything goes wrong, I'm going to go ahead and reject with an error. Oh, so that's off. I can't do anything to it. Otherwise, if it's okay, I'm going to go ahead and detangle it, shampoo it, and then resolve this promise with shampooed hair. So I can go on to the next step. And now I can have do hair return a promise. And this allows us to chain our promises with .thens. Upon completion of an asynchronous functions processing, we can go on to the next step that returns a promise, which means that we can do another .then and complete another step in the process. And also notice that .thens come after the return of an asynchronous function. So this also means that we can handle errors in one place, which allows us to remove all those if-elses we had in our callback hell and clean up our code with that .catch. So do my hair, then .then, go out in the town. Woo. And here's a side-by-side comparison. And so now it's much easier to read. You know, no more pyramid of doom, just asynchronous code that reads synchronously. But this can be improved even more with AsynchroWAT. Oh my God! So this is kind of cool. If you put the async keyword in front of a function, it automatically makes it a function that returns a promise. And if executing code returns a non-promise value, it'll just wrap it in a promise. And await makes JS wait until the promise is settled, and then returns the result. And this only works with async functions, so function with that keyword. Just a disclaimer here, like this is a newer feature of JavaScript, so you might have to figure out how to make it compatible with browsers and all that stuff. But it is a cool new way to handle asynchronous behavior. And so now I can go ahead and rewrite my do here function with an async in front, and then wherever I have an asynchronous process, I just put in a wait there, the function waits, and it allows me to go on to other things in my do chores function. And so looking at this, you can see all three approaches here. Now, these are all correct ways for handling asynchronous behavior. But as you can see, it gets progressively easier to see what is happening in the code. Ooh, look at this. It looks so nice and easy to follow. Someone that didn't know JavaScript could probably guess what's happening here. So now my do here function is rewritten with AsynchroWAT. I can go ahead and call do chores, and everything works the way we expected. I can start my hair, go do something else, come back, do another step, do something else, come back to another step. And now I have officially finished my chores, and my hair is done, and now I can go out and flaunt it, hair did. And look at you. Not only do you know now how to slay natural hair, but you can also explain asynchronous programming with JavaScript. Girl, what? So in closing, I just want to say being a junior dev is no joke. It is not for the faint of heart. And if you're feeling like a dummy, it's okay. You are a dummy, and so is everyone else you work with. But seriously, all jokes aside, this is what is exciting about being in programming, right? Like, everyone is trying to just figure things out. We don't always have the answers. We're always learning every day. And if you're a senior dev training a team or someone that's new to development, maybe non-traditional background like myself, I was in education and nonprofits before I came to tech. Again, just know this stuff isn't always apparent. Try to remember where you were here, when you were here, have some empathy, and share your knowledge. You know what they say, those who can teach, and those who can't just sit in a corner and code by themselves. And if you create tech training materials, think about how you can represent all the diverse people in this field that make up tech. Originally, I was going to write this whole talk with laundry as my main example. That shit is boring. And I started having flashbacks to my days watching online tutorials, looking at stupid-ass examples about torpedoes and, like, counting cattle for real. Some of y'all know what class I'm talking about. And it was just so irritating to me that there were no examples, like none of the materials were anything like anything that I had personally experienced. And frankly, sometimes it just made it hard for me to understand the content that I was supposed to be learning. So it's important to me that everyone sees themselves in this field, no matter who you are. It makes a difference. And I always like to give shout-outs to my inspiration. So I always do this when I do a talk. These are the people who helped me shape this idea, who inspired it, helped give me feedback. So the people on this slide are my friends, my coworkers, my boyfriend's up here too. And I also want to do a special shout out to Amy, because she is actually inspired this talk. So I did a zine workshop with her at a conference called Write, Speak, Code, which folks, yeah, where my girls and MBs at? Yeah. This conference focuses on getting women and non-binary people writing and speaking in tech, and it works. You should sponsor it. And I do this because people think that people who do conference talks just come up with amazing ideas on their own and just brilliant ideas falling from the sky, and that just is not the truth for me. My brilliant ideas are always a combination of the awesome, brilliant people around me who I draw inspiration from. So if you're thinking about doing a conference talk, just know that you have a community of support that you can tap into. It takes a village, and we have your back. Thank you.